We're back to this sixth video on the crash course to Python, and I will start from where I left off in my last video. In the last video, I was actually trying to use a while loop to check for a Boolean function where I will say is something equal to something that been inputted from the keyboard by the user. And what I will do, I will use a lower function where it actually takes the text. It doesn't matter if it's in lower or higher case, and it will convert it to a lower case. And then if it will compare it to this text, which is in this comment, and it says it's quit. So if it actually matches quit, it will, if it's different, it will go into the loop. If it matches it, then it will actually exit the loop without doing anything. Okay, so let's run this and see what we get. So it actually prompts me to enter some text. So if I say hello and enter, it should says you entered hello. If I go and change that to hello and in capital and enter, it says you entered hello. If I enter quit, it should actually quit. Now you've entered quit, so it doesn't prompt you again to enter anything. Now if I run it again, just for the sake of using small letters, and I enter quit, and if I run it also, it should actually, I did not run it, it's actually enter, and it should say you've entered quit to come out. So this is how this works. So it actually, this function here, it's called on this input, so it will take whatever string you there, and then you apply this function to it, and then compare the logic. When it's actually true, you come out. If it's not true, you execute the statement below it, which says print what you entered, and then it says print you entered something like this. So it asks you to enter, and then it says you entered this. So this is very simple, and it's a nice way of actually checking what you have entered. In this cell, I want to use while loop to iterate through some integer count and to actually execute some statement. And once the condition is not satisfied, then we actually exit this loop, and we actually continue with the statement that comes after the loop, which is usually it will contain too many statements when you are writing a function, and you use that function or that code within your loop or within your code. Can you see in here what we have done? We have actually iterated through count, because count will, while it's less than 0, so first of all is 0, then it actually comes in and it will print you are inside the loop, and then it will increment and go back, still 1, it's less than 3, it will print again 2, it will actually print again, and when it comes to 3, it's not less than 3, therefore it comes out and it will print the statement after the loop. So it's very simple to verify how many times the loop is actually going to execute, and then you can come out of the loop and you continue with your code. Okay, now this is an infinite loop because I'm using a true. While it's true, it will continue iterating. Okay, and what I want to do here, I want a user to enter some text, and then it will compare the text as we did earlier with quit, but this time we are using exit, and I'm using, once I type exit, it should actually execute this break, and I will come out of the loop. So if I run this, it says enter, and if I type whatever I type here and enter, you actually continue entering. So can you see? And then if I type exit, it should come out of the loop. Now, Of course, I used lower. And it's exactly the same logic. If I enter capital or lower letters, it should be converted to lower and compared to this text here. Next, I want to use the function range. And in this case, what we are doing, range will actually generate a sequence of numbers up to a range that you specify. But this range can actually take start, stop, and the step, same as we did in as you do in the C and Java for loop. So if I just pass it just one parameter, it takes it as the logic, the maximum where you're actually going to stop, which is the stop condition. And in this case, the stop condition is actually number 5. So in this case, it's supposed to, while range is not equal to 5 yet, it hasn't reached 5, then it will continue printing whatever the number is. And number will start with 0 because the first value this range will generate will be 0, and it will go all the way to this maximum range which we have supplied. So if I run this cell, then I get 0, 1, 2, 3, 4. But when it reached 4, it actually goes and it says what we have done for maximum is 5, and we've reached 5 here because this is 1, 2, 3, 4, 5. So it actually generated these numbers from 5 times from 0, so it reaches 4. It will not generate 6. If I want to do that, then I will need to put 6, and it will actually give me 5. From 0 to 5 will be 6 anyway. Okay, then specifying start and stop. To do that, I will put the start and I will put the stop. And in this case, I'm saying you start from integer 2 and you end up at integer 7. Okay, so it's 2, 3, 4, 5, 6, and 7. And how many times did it actually? 1, 2, 3, 4, 5, 6 times. And if you count between 2 and 8, it's 6 times. So it actually generated a number between 2 and 8 6 times, and this is the result, and it actually prints the number it generated. If I want to put the 3 parameters, which is start, stop, and the step, where I can say the increment is condition is entered here in the 3rd parameter, then I can do that. And it says you start from 1 up to 10, but you are actually incrementing by 2. So it will print 1, then it will print 3, then 5, and 7, and so on. So if I run this, can you see 1, 3, 5, 7, and 9, and then the next number would have been 11. Therefore, we will stop at 10. So the next number is not generated. I can make this 3, and then it actually 1, 4, 7, and so on. Okay, I can make this into 1, and then this way it will actually give me the 10 numbers. So it's up to me what I want to put in this condition, because most of the time we are looking for numbers which within certain range. I can actually ask it to do even numbers, odd numbers, whatever it is. I can change it in this condition here, and it should give me that logic. Also, we want to use a range in a list, and we want to create these numbers in the list. So what do? I created a parameter called square, then I assigned to it a list, which is, as you can see, it's actually these square brackets. And then I have a function which is x squared. I want to square every number. So the entry in this list is going to be the square of every number generated in this for loop, and I use the range value, the range function, to generate numbers up to 10. Okay, and then my list should have the numbers from 1 to 9, and all is from 0 to 9, sorry, and all has to be squared. So let's run this and see if it gives us that. So 0 square of that is 0, 1 square of that is 1, 2 square of that is 4, 3, 9, and it goes all the way to 9, and 9 is 81, the square of it. So I can create the list, and we've seen this when we were creating lists, and now I am actually repeating it here for you. Now I can see we've already done this here in the first one, the range, and we can actually use the range just to print the numbers for us as we did before, and it actually now, but what I'm doing here, I am actually using a function reverse, and we've seen that reverse function when we created dictionaries before, and we took the components in the dictionaries and the lists, and we reversed decrementing the maximum value in that range down. So it starts from 4 and it goes all the way down to 0. Okay, and I can create a list using range between something and something else. So it will actually go between 1 and 6 in this case and create this list for me. And as you can see, it actually created the list in there for me between 1 and 6. Therefore, it has 5 numbers between 1 and 5. List comprehension, we've seen that in creating a list earlier before, and we want to use this function square, and I used this earlier, this logic, I used it here. Can you see? So I am actually repeating it for you, and it actually gives me the values. You can change the conditions here. You can make this into cube or quadratic, whatever you want, you can actually change it. Now, let's see. I want to use to filter numbers, and what I do, I have a list created, and I want to create another list where I am only looking for even numbers, and the condition here is the if statement, and I want the value of x to actually be divided by 2 and return the modulus, and if the modulus is equal to 2, then that if statement is satisfied, and we can actually enter the value into our list. If it's not satisfied, we do not enter the value in our list. So if I run this, you can see that it only entered the values 2, 4, 6, and 8. Now, if I can change this here to not equal, then it will put in the odd values for me again. So it's very simple again. Now, if I repeat here, it actually now I have two values, x and the square of x. And I want to use range again up to 7, and it should actually give me 7 values in this nested. It's actually a list which contain these tuples. So I'm creating a tuple within a list, and you can see the first tuple is actually got 0, 0, 1, 1, 2, 4, 3, 9, and the number and its how shall I say, the number and its squared value. So I can take nested lists and I can flatten them, where I can actually have a list continuous, one list. Instead of having a list which contains 3 nested lists, I can just create one list with all the values from 1 to 9, and I use the for loop, which actually enumerate over the rows, and it will read the numbers in each row, and it will just insert the number into the list as it is here. So if I run this, you can see that it actually took this nested lists and removed the nested and just iterated over the values row by row until it finished all the numbers within the rows. Okay. I have this list here, which is 1, 2, 3, 4, 5. I want to create another list which contains the square of it. If the modulus does not equal 0, then we actually enter the value. If it's not equal 0, then we actually enter the value itself into the list. If it's equal to 0, we square it. If it's not, we enter the value itself. So let's see, 1, 2, 9. So this one is not 1 is actually true, therefore we enter the square. 1 is 1. 2 is not equal to is actually equal to 0, therefore we enter the value because this condition is not satisfied. 3 and the value is not equal to 0, therefore we actually go and enter the square of that. Then the 4 is equal to 0, therefore we just execute the else and we just put the value. 5 and so on until we finish the list. So this is a nice way also of selecting something and executing some logic on it. Okay, and that's what we have done here, and it's very simple and easy. And we have this code here, and as you can see what it will do, it actually takes this string which is created, hello world Python, and it will actually go and check the length of the word for word in word. So it will actually go and count the actual characters which constituted in each, or the number of characters for each word. Okay, so it will take the length of the word and then for word, which means it will take the length of that and print it, and then it will iterate, where it will increment the index. It was at the first index, which is 0, then second index, which is 1, and then third index, which is number 3, and so on. And it will continue that way until it finishes. And for each word, all it gives us is just the length of that word. So it counts these and it gives us the length, and it enters the length into the list. So I've converted a text list into an integer list by entering for each word the length of that word into the new list that's being created. So this is how it's actually done. And then I wanted to show you again how we can actually flatten, where we remove these nested lists and just create a list. So it actually, what is done is transposed, which means it actually take the list at position 1 or index 0 from the first list, index 0 from the second list, index 0 from the third list. So what we've done, we were actually looking at it in a row format. Now we are looking at it from a column format. So if you look at this, this is actually column 1, column 2, column 3, and this is how it's actually done when we are looking at the transpose of a list, which is nested list in that form. So let's look at how we use function, how we create them, how we use them, how we manipulate them. And we are going to use the functionalities that we have learned so far, which is the logic of the for loop, the creation of lists and dictionaries, and we need to know how to access these different location within lists and dictionaries and different indexes and so on. So a function in Python are blocks of reusable code that perform a specific task. Because if I want to execute a task many times, then I will create it into a function and I will just call this function, and it's much easier for me to actually do that. For example, if I wanted to calculate the square of a value, then every time I just create a function called square, and then I will pass the value to that function, and it will actually just return the execute. So a function can take a value or not, and should return something. So it can take a value or it cannot take a value, whatever it is, but it should always return something because we are interested in its returning. So let's look at the first simple function that we create. We use the keyword define, so def for define, and then we put the name of the function, and then we say it's a function by declaring these parentheses. Now we can pass an argument into this function, or we can create it where it doesn't actually take an argument. And in this case, it doesn't take an argument. And whenever you call this function, it should actually execute the content of that function. And what's the content of that function? It's a print statement. That's all it is. And please remember the indentation where you start to actually define that you are within this function. Because if I run this now, it actually gives me this. Now, if I remove this indentation, which is there, and I try to run, it will give me an error because there is the print supposed to be in the function, but it's not in the function. The only way it can be defined that it's in the function is by actually saying we are there, okay, at this indentation. And to know the indentation, the correct indentation, all you need to do is just go to the end of this, hit retain, and it will take you to the correct indentation. Okay, and to call the function is just by writing the name of the function and hitting return, and it should call that function for us. So this is how we create a function, and this is how we call a function. Okay, let's run it again to remove this error. And it says, hello, how are you? Which is what we actually did here. Now let's look at a function with parameters. That's a function that's going to take some argument, okay? And I created a function using div, and then I called greet with name. So the function says, you have to greet somebody, but you have to pass the name to this function. So if I pass a name there, this is going to be used in my formatted print statement. And the formatted print statement says if. So the compiler understands this is a formatted, and it should take an argument after this part of the print statement. And the argument is going to be in curly bracket, and whatever we passed here, it will be actually inserted into our print statement, and it will be printed. So if I run this, it should actually, and when I call it here, I passed an argument to it and the name Adam. So if I run this, it should actually say hello Adam. What it means, it actually calls this function, which requires you to enter a name. Whatever you enter here, it will be inserted into the formatted print statement. I call the function and I pass to it Adam, okay, and it says hello Adam. I can change that and I can say hello Ali, okay, or Jack. Okay, now if I run this, then it should say hello Jack. So as you can see, this is powerful, and also you can actually use it. Now you can actually use a function with default parameters, okay, and the default parameter in this case is equivalent to guests, and I'm using name here. It could be like a key, okay. And then what I do, I print hello, and whatever name is actually going to be printed here. So I will actually pass something there to it, and it should give me the default. So if I run this and I passed it Bob, hello guest, which is I wanted it to print the default, which means I don't want, even though I pass something to it, but or if I don't pass anything to it, let's say I run this without actually passing anything to it, then it should actually come back and tell me whatever I formatted here, and I said it's a guest, okay. That's the default value, okay. Now if I enter something, then this something that I have entered will overrule the default. It will replace the default in my print statement, and it will execute by entering the default here. So if I change this to Adam again, then it should actually bypass. But if I comment this and I don't enter anything, then it's actually just running that which says hello guest. As you can see, just hello guest. Now if I comment this and remove the comment from that, and if I run it, then it will actually say hello Adams. Therefore, you can see I can put a default value. So if I forget, or I am calling this function to do something, but somehow there is no data. I'm reading some data and I'm passing it to the function, and somehow I went to the data and the data is missing, i.e. it's not present in my folder. Therefore, I don't want an error to take place. Therefore, I can enter this so I can avoid the error, and it will give me a default value. Okay, so this is what we can use this as, like this in this scenario where there is some missing values, for example. Now we can also create a function which can take multivariables, and in this case I want to enter two values, x and y, and then I want to actually execute some logic on this x and y. So what did I do? I actually use the first one, which is the square I told you. So you pass a variable to that, and the function will return the square of whatever number you entered. So if I am actually have a list of numbers and I want to square them, then what I do, I will create a for loop, and within that for loop I will call the function square, and I will pass to it the numbers that I want to square, which are the numerates in that list. So it will do the work. So as you can see, it actually, if I entered 4, it gives me the square of 4, which is 16. I can assign that to a list and keep adding values in there. Now this function here takes two arguments. This one takes one, this one takes two arguments, and there is some logic that it needs to execute. So if I call this function and I pass to it the two arguments, which is 30 and 7, it should actually add them for me and print the result. And you can see 37. If I make this 29 and execute that, then it actually gives me 36 and so on. Now in this part of the code, what I'm doing, I'm actually passing an argument, and then I am actually getting the product of the value that I am using. And what I'm doing, if I actually pass 2 and 3 to it, then it actually takes the first argument and it will multiply it by the second argument using the loop inside here. Okay, it takes result is equal to 1, the first result, and then it will take number in argument, which is there, and what do? I just multiply it, and if it's one argument, if it's two arguments, we'll take the first argument, multiply it by the second argument, and it will return the results. And if it's 3, then it will take the first, multiply it by the second, and multiply the product of them by the third variable, and so on. So if I run this, you can see that it actually, when I supplied it with 2 and 3, just multiplied 2 and 3. When I supplied it by 3 arguments, which is 4, 5, and 2, it took the 4, multiplied it by 5, and then it took and multiplied it by 2 because it actually iterated in the number of arguments here. It took the first argument, multiplied it, and then it took it took the second argument, which is now containing the product of the first and the second, and multiplied it by the third and returned the value. So this is a nice way of actually calculating the product of a list if you want, and it can be very helpful. Okay, now we can use the keyword to print the contents. Okay, and the keywords here are actually in some form. They are actually given to us. So if I say print this, it will give me name is Alice and age is 25. And what did I do? I will pass name and age. Okay, and in this case it should give me the value for there. It will just return the actual values which we have entered. So name will be by default, and then it just give me the age, the name that's entered, and age will be the key, and it will give me the content which I entered for age. So this is the order in which they come. If I change the values that I enter, it should actually give me different values. So let's run this. It gave me this. So let's change this to 25 and this to Alice. And I put it in there, and let me run this. Say name is 25 and age is Alice, which is what is done. It doesn't actually check for the type. It actually just go and enter the values into these locations. So it's forced by order because we use the key to actually order this. It doesn't matter what I actually enter. Okay, so if I bring this back to Alice, and bring this back to age, which is 25, and if I run it, you can see that it's actually taking it by order, and it's actually quite nice to do. So this will take us to the end of this Jupyter Notebook. Let's jump straight away into the next Jupyter Notebook, which is Jupyter Notebook 4, and the final Jupyter Notebook in the series. Now, what I want to introduce in this Jupyter Notebook is the function Lambada. And the function Lambada is one of those functions that we are going to use quite a lot. So it's also known as anonymous function, which is actually a good way to create a small one-time function. So you use this function one time in Python, and they are defined by using keywords. So let's look at this. I want to create this square, and I call this variable, which is going to be the square of whatever I enter, and I use the function Lambada, and I enter a variable, and the logic that Lambada will do, the function, it will take whatever I entered in this case, and it will actually square it. And squaring is using these two asterisks, which means it's x to the power of 2, just to remind you. So that's what this function do, and it's a simple way. It's a fixed one-time function. Okay, you enter this variable. I defined it that way. It actually takes one variable, and it will return the square of that variable. So it's actually takes the variable, and we have to define the logic. If I said to it, it will actually take two variables, and I want the logic to be to actually add these two variables together, then it will do it. I want them to add these two variables and then square it. It will do that for me as well. So let's run this and see. And I call this square, and I will pass to it 5. So this function square, once it's created, it will actually require me to enter something. Once I enter, it will actually give me the square of that number. So can you see here, when I run this, it actually gives me 25 because it took 5 and squared it for me. So if I use 3 or 2, it should actually give me the square of that also. So it's a nice way of utilizing this function. Look at this. The second function, I am using a function, creating a function called add, where I am using Lambada to create this function. Now Lambada will take two variables. So you can see I separated the variables by comma, and then I entered after the asterisk here, after the colon, sorry, the logic that this function is going to do, which is actually just adding these two entered variables. And if I call it, I will call it the same. Result I'm calling add, and I'm assigning it to results, and then I'm passing the two variables which are 3 and 4, and it should give me the result in this print statement. So if I run this, it should give me 7. Now if I make this into 13, then it should give me 17, and so on. So as you can see, this is a very simple way to utilize this function lambda, and it's easy to create these functions. All I have to do is to define the number of variables that this function is actually going to take, and then define the logic that the lambda is going to execute. Okay, so now I am actually going to pass components from a list to this lambda, and I'm going to use the lambda within a map. And lambda is most of the time is actually utilized in either a map or a function, in which we can actually take the values, iterate, and execute the result within the function. So what I'm doing, I'm creating a list, and I'm using a map function, and there in the map function I use the lambda to create a function, and I take one argument, and it gives me the result that actually of square in it, and then it actually enters the number into the list. So if I run this, can you see it actually give me 25? If I change these values here, add some more, it should actually give me further result of that, and so on. Therefore, it's a nice way also to use this function to create a list. Okay, all right. If we want to use lambda now to actually sort, then we can actually use it, because we enter a variable, and then we execute the condition, and the condition should satisfy whatever we actually ask it to satisfy. And in here I am actually trying to enter to find the age for each of these variables, and I want to sort it. Therefore I am actually passing this function into a sort, and it will actually go and sort them for me based on the condition. And the condition is what? Age, which means it will take all these ages and it will sort them from lower to higher age in that order. Okay, and then as you can see, it's 25, 22, and 28. So when it comes to print these dictionaries, it will not print them as they are, because this is index 0, index 1, index 2. If I'm printing normally, it will come Alice age 25, Bob age 22, Charles age 28. But because I want to sort it, okay, and this way it will take the smallest age and print it regardless of the index. Okay, so it will be index based on age in this case. So let's run this, and you can see that the minimum age came first, then it actually goes up to the highest age. So it's a nice way of actually sorting a list or a dictionaries or whatever you actually looking at. Okay. Now I want to use lambda function with conditional expression, i.e. I want to use it with Boolean expressions. Okay, and what I have done in this case, I want to actually check if a number is even or not. So what I do, I actually use the function, I enter the value, and then the condition I'm actually checking to see it will be true if the entered value divided by 2, the modulus of that is equal to 0, then it will be even. If it's not, then we actually execute this, which says it's false, it's not even. Okay, then we actually go and pass these numbers. So let's try the even one first. So I comment this, and if I execute it, it says number 8. Yes, it's even, because it actually we entered 8 to lambda here, and then it actually goes and take this value which we entered and execute the result, and it's actually satisfied the condition. Therefore, it says it's true. It entered true. If it actually doesn't satisfy the condition, then it will go to else it's false. In this case, it's satisfied. Therefore, it says is even. Okay. Now, if I uncomment this and comment the first one, sorry, the one above, which actually says for even, then now if I say, what did I do? I entered 8 it should be the hash entered there. So if I run this, yes, 7 is not even, therefore it returned false for us. Therefore, as you can see, it's a nice way of actually checking whether something is even or odd, or any other logic that you actually try to find. Again, I am going to use Lambda with filter to create a list. I have given it a list and I want to actually create odd and even. Okay, and what do? If I look for pass the list, it will take each of these components which we are entering, which is x. It will divide and will say it's actually true. Then it will actually print the number which is the even numbers for us. So if I run this, it actually gives me the even numbers in there. Now if I change this and make it not equal, it will print for me the odd numbers and so on. But I am not interested in doing this because we've done it so many times so far. Okay. Now that's about filter. Let's see how we use the map function. Now, again, I have created a list containing 1 to 5, and then I want to square the numbers, and then I want to print these numbers, but I am using a map to create the list with the help of the Lambda function. So if I run this, I will take the number and I will map, i.e. include the square of that into the new list which we are creating, and it works quite nicely because I have already explained the logic here. I'm not going to go through explaining that again. Okay, so I want to use map function to convert temperature from Celsius to Fahrenheit, and you need to understand the logic that you take the actual Celsius temperature, you multiply it by 9/5, and then you add 32 to that, and that will give you the equivalent Fahrenheit temperature. So what I did, I have a list of these temperatures, and then I want to create another list using both map and Lambda to convert the temperature to Fahrenheit. So it will take 0, and then it will multiply it by 9/5, which will be 0, and then I add 32 to that, and that will be the equivalent of this Fahrenheit temperature. Then, of course, because I am actually using a non-decimal, non-integer value here, then my result is going to be represented as floats, and you need to understand this. Okay, so the next value is 10. 10 times 9/5 plus 32, and it will be 50. The next one is 20, and it will be 68, and so on. So this is how it actually works. If I run this, it actually works quite nicely, and I have actually used the map and Lambda to do the conversion for me according to logic. So it's not just a square in this case. I can put whatever logic in here that I want. It will actually execute that logic for me without a problem. Okay, so I have two lists, list 1 and list 2, and I want to use the map function to multiply these lists together. So what I did, I actually passed a function Lambda to my map to try and create the list. And in this case, what did I do? I pass the number, which is actually the first number in my and then I will actually add to it 2 times the number in the next list at the same index. Okay, and then I will say list, I pass to it list 1 and list 2, then it actually knows because it has to iterate through them. So if I run this, you can see it actually gives me 1 plus 8 is 9, 2 plus 10 is 12, 3 plus 12 is 15, because it's actually 2 times whatever value here. And that's what it actually does. So I can define any logic here and it should execute it without a problem for me. So this is important and it's useful for you. Okay, so let's look at the next piece of code, and the next piece of code is actually using filter to filter even numbers. And this we have seen before. We've seen how the lambda will actually filter for us, and once you pass this into the filter, whatever the logic here is, it will enter that number into the list. So let's see. 1, if you divide by 2, it does not equal 0, therefore it's dropped, it's filtered out. 2, yes, then we enter 2. 3, no, then we drop 3. 4 is yes, then we enter 4. 5 is no, and so on until the end of that list. So it's a nice way of actually filtering based on even numbers. Okay, we want to use strings, and now in this I have created a string which has 5 names: Alice, Bob, Charlie, David, and Anna. And I want to filter based on the first letter of each name. And I use lambda where I pass the name, and then I use a function which start with, and it only looks at the first character that is passed to this function, and if it's equivalent to what we pass to it, then it will actually include it in the list. If it's not, it will exclude it. So let's check now for the letter B and see what happens, and it only return Bob because that's the only thing with letter B. If I put A, then it should return the names with the letter A, starting with letter A, and I have 2 of them, Anna and Alice. So I have Alice, Anna, both starting with A. If I change this to D, then it should actually give me just David. So if I bring this back to A, then it will be correct logically for what we are checking for in the code. And the last thing is actually using filter to filter prime numbers. And again, in here, it's the logic that you can actually use. I have defined a function called isPrime, and then I will actually pass this number to this function. So this function takes a number and it will execute the test. If number is less than 2, return false. If it's greater than 2, then this one is actually not executed, and then it will go to the next one. For I in range 2, and you multiply the number you've entered by half and you add to it 1. Okay, and then if number, the actual logic is you divide the number by I, and then if that's equals to 0, then you say that it's actually you return false. If it's not, we don't execute and we return true. So let's see if I run this, what happens. I have the value which is 2, and if it's not less than 2, so it drops 0 and 1. So if the value is 2, which is not less, then it actually goes and does not exclude that, so it's not false, we don't return false. Then we say it's actually we have a number for I, and I need to check. Now it's 2. I will multiply the 2 by half, and then I add 1 to that, and it's 1 plus 1 will be 2, and I will enter it. Okay, and this I need to check this for it, and is it actually equivalent to 0, the remainder divided. If it's divided, then I actually go and return false, otherwise return true, and that is my function. Now I will pass a number 40, let's say, and the range now become 40, which is here. The stopping is actually 40. Therefore, what happens? It should iterate through the numbers and execute this logic here. So it starts from 2, it will take 3, 5, 7, 11, 13. So it's taking all odd numbers, which are prime numbers in case, because we are actually executing this here to try and only generate prime numbers for all the values that we will include in this range, and up to 40 in this case. And the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and 37. Now, this takes us to the end of our crash course on Python. In the next course, I will be talking about, in the next video, sorry, I will be talking about the library NumPy, and I will start explaining what NumPy is and how we actually use NumPy for in our Python codes. So thank you very much for watching the video, and I hope to see you in the next video.